Section 6.4, trigonometric identities. So now you're going to be introduced to two new identities which you need to memorize and be able to quote straight away. So remember from before, in year 12, there were two identities, sine squared plus cos squared equals 1, and also tan theta is sine theta over cos theta. So we're going to use both of these in this, improving those new identities. So you start with sine squared theta plus cos squared theta equals 1. So we're going to find tan and sec. So to make that into tan and sec, both tan and sec have cos in the denominator. So we are going to create cos in the denominator. Since we've got squared terms, we're going to divide everything by cos squared theta. So you obtain sine squared theta over cos squared theta plus cos squared theta over cos squared theta, and then 1 over cos squared theta. So here we've got tan squared theta plus this one cancels to 1, and this is sec squared theta. So rearrange it into 1 plus tan squared, because this is how we normally quote it, and you've got it proven. So it's proven. To prove the second one, you again have the same starting point. Sine squared theta plus cos squared theta is equal to 1. This time we are creating cot and cosec, so you want sine in the denominator. So divide by sine squared, because our terms are squared. You got sine squared over sine squared theta plus cos squared theta over sine squared theta, and 1 over sine squared theta. So here that cancels to 1. Here we've got cot squared theta, and you've got cosec squared theta. Again, this is what we were trying to prove, so it's proven. Learn how to prove, how to do those proofs. Start with sine squared plus cos squared equals 1, and you obtain these two proofs. You could be asked to prove them in your exam. Remember, from now on, when you've got tan or tan squared, you'll be able to replace it with sec squared, and vice versa. When you've got cot squared, it goes really well with cosec squared. You'll be able to replace it with cosec squared, and vice versa. Okay, so we're going to look at example 10. We are going to find sec A and sine A when you've got tan A being equal to minus 5 over 12 and A is obtuse. Okay, so we're going to use our identity. 1 plus tan squared is equal to sec squared. Substitute minus 5/12 to get the value of sec squared. So sec squared A is equal, so this is going to be 25 over 144 plus 1. That gives me 144 in the denominator, and then 144 plus 25, 169. So sec squared A is equal to, let's square sec A, take the square root, you've got 13 over 12, but possibly negative or positive. So now to identify whether it's positive or negative, we've got to consider sine, the fact that A is obtuse, and when A is obtuse, if you look at the cos graph, there you go, here's our obtuse angle, so it's minus. So that gives me sec A must be equal to minus 13 over 12. Okay, to find sine A, well, once you've got sec A, you've got your cos A. Cos A is equal to minus 12 over 13. And you've got two ways of finding sine A. So one way of doing it is, again, use identity from here 1, sine squared A, I'll rearrange it, is equal to 1. No, actually not. Plus cos squared A is equal to 1. So sine squared A is going to be 1 minus cos squared is minus 12 over 13 squared. That gives me 1 minus 144 over 169. Okay, I'll write it here because I'm running out of space. 169 over minus 144 gives me 25 over 169. So that's 5 over 13. Hold on, let's not rush it. So sine A is equal to plus or minus 5 over 13. But is it going to be positive or is it going to negative? So if A is obtuse, sine is clearly going to be positive because there's between 90 and 180. So sine A is 5 over 13. Okay, I'm just going to quickly remind you of a different way of finding the value of sine when you know that cos is equal to minus 12 over 13. So if cos is obtuse, this is equal minus 12 over 13, what you're doing, you are just finding the equivalent of for sine if cos is an acute angle. So it's equal to 12 over 13. So you are going to assign the sides of this right angle triangle. You're imagining this is your A. Opposite is over here. Adjacent will be 12 and hypotenuse is 13. There you go. So to find what the opposite is, you're going to do 13 squared minus 12 squared, square rooted, and that will give you 5. And now you are able to find your sine A, 5 over 13, plus or minus. You are not sure yet whether it's going to be plus or minus because you need to consider that our A is obtuse. A is obtuse, meaning between 90 and 180, so sine must be positive. Let's move on to example 11. We're going to do a proof of the left-hand side. Cosec to the power 4 minus cot to the power 4 is equal to that expression. Okay, so this is quite a difficult question. So I would memorize the way of doing it. If you've got two trig functions with a difference of whether to the power 4 or even power, could be the difference of 2 squared, or the to the power 4 or to the power of 6. Or to the power of 8, that tells me that you are dealing with the difference of 2 squares. So you can think of it as cosec squared squared minus cot squared squared. And then you can pop these into 2 brackets. So we are factorizing these. There you go. Now, think about identities. Now, it doesn't help the fact that you are aiming for cos, and you've got cosec and cot here, and cosec and cot in both examples. But what you may choose to do is to use identity that involves cosec and cot. So remind yourself of this identity. So it's 1 plus cot squared theta is equal to cosec squared theta. That gives me 1 is equal to cosec squared theta minus cot squared theta. And then luckily I can see that I have got that bracket, so this is equal to 1. So we are dealing with cosec squared plus cot squared. cosec squared theta plus cot squared theta. Now here we want an answer that just involves causes. That means you need to change these into sine and causes and hope that sines will disappear somehow. So write it as 1 over sine squared theta plus cos squared theta over sine squared theta. There you go. And you've got 1 plus cos squared theta over sine squared theta on the bottom. And how do we make that sine squared disappear? Look at what you are aiming for. You've got the numerator. Don't touch it. Leave it as it is. And then in the denominator, you can change it into 1 minus cos squared theta. So this is our right-hand side. Proven. Okay, in the next example, I'll rewrite it somewhere else. Okay, created a little bit more room. So over here, you've got a bit of a dilemma because you might want to start with the left-hand side, which looks like that, sec squared theta minus cos squared theta. And then you can be, I don't know, you can change it into causes. But then you might think, well, that's wrong because I want to keep my causes, sec. So why am I changing into causes? Well, that's fine. You can change that because you can change the right-hand side into sine and causes. And then hopefully, like in the example before, the sines will somehow be able to be replaced with causes. So that's what I'm going to try and do. So if you've got 1 plus sec squared on the right-hand side, let's see, what could I do? Well, I can change that into 1 over cos theta. I could expand the bracket, I guess, as well. So let's just expand it first. Maybe change this sine, or sine squared can definitely be changing to 1 minus cos squared. So I'll just remind myself of doing that. And this one here, you will have sine squared times by 1 over cos squared. And that is tan squared. So you've got 1 minus cos squared theta plus tan squared theta. And guess what? I don't need to do much now because I've spotted that 1 plus tan squared, our identity, can be replaced with sec squared theta. And I have got 1 plus tan squared here. So using that, I can replace it with sec squared theta, and I've got cos squared minus cos squared theta there already. So this is the left-hand side. So that's quite a tricky example. Okay, so last example before exercise 60. We're going to do a little proof, and then we're going to use this proof. Oh no, there's 2 examples, to apologize. No, I'm mistaken here. We've already done that one. So it's example 12. It is the last example, but there is no proof here, although we are going to use an identity. So remember, if you've got an equation, it says to solve. You've got cosec and you've got cot. Cosec, especially one of them is squared, and cot have a lovely identity that can be used. So there you go. 1 plus cot squared is equal to cosec squared. If you had, it's just like with sine and causes. The one that's not squared, this is the one you want to keep. The one that's squared, that's the one that we want to replace. So you've got 4, 1 plus cot squared theta minus 9 is equal to cot theta. So it's 4 plus 4 cot squared theta minus 9 is equal to cot theta. We're going to have 4 cot squared theta minus cot theta minus 5 is equal to 0. So we have got a quadratic equation, so we're going to try and factorize it or solve it in using formula. There you go. So we want to have 5 being with a minus and 4 with a plus. There you go. So you've got two possible equations. Cot theta is equal to 5 over 4. That gives me tan theta is equal to 4 over 5. And here cot theta is equal to minus 1. That gives me tan theta is equal to 1 over minus 1, which is minus 1. So theta is equal to tan inverse of 4/5, and theta is equal to tan inverse of minus 1. So this one here will give me minus 1 for tan is 135, and then plus 180 is 225, and then tan inverse of 4/5, we've got 38.7 at 180. You've got 218.7, which is 219 to 3 significant figures. Let me just double check this one. 135 add 180. Okay, that's clearly not right. 315. Okay, so you've got 4 solutions. I'll just circle them for you. Okay, so ready to go on to exercise 6D.